Hey there, my name is Adam Keller, and I'm a senior developer advocate on the container service team here at AWS. And today we're going to talk about architectures and strategies for building modern container-based applications on AWS. Today we're going to talk about what a modern application looks like, and we'll actually go into defining some of the characteristics of a modern application. And from there, we'll segue into some of the architecture strategies that fit with a modern application paradigm. Then we're going to talk about containers. We're going to talk about the benefits that they offer. And then lastly, we're going to dive into some strategies around running your containers on Amazon ECS. So what is a modern application? Modern applications are built with modular architectural patterns, serverless operational models, and agile developer processes. They allow you to innovate faster, reduce risk, accelerate time to market, and decrease your overall total cost of ownership. Modernization is a journey, and you don't have to boil the ocean at the start. You start small, you prove the model, and then you grow. But in order to build a modern application, we need to embrace modern architectures. And oftentimes when we talk about modern architectures, we talk about microservices or modular architectures. This is where you might hear the term microservices or service-oriented architectures. By moving to modular architectures and breaking up the application into smaller units, teams can deliver code faster and independently of one another. In addition, the scaling model changes. So each component can set its own scaling patterns and not have to rely on the rest of the application to scale with it or to determine when it needs to scale and when it doesn't. With the code broken up into smaller components, the dependencies will become loosely coupled from one another, enabling fault tolerance at a level where if one component of the service is degraded or down, the application as a whole can still remain available. Lastly, teams can embrace polyglot architectures and aren't subject to a single programming language. So for example, if you have a team that's working on a service that prefers to write their code in Go, they absolutely can, because if they're writing an API service, the code that they write that API service is irrelevant to the other APIs or other services that communicate with it. So really, it gives the power to the team that's operating that code and that application to choose what model fits them best and what programming languages work best for them. So with all of that said, how can we embrace modernization? Embracing modern architecture requires a culture shift. This is following DevOps principles, removing silos and building security and testing into the automation and into your pipelines, and providing faster feedback loops. Defining your infrastructure as code is key. Whether you closely couple your infrastructure as code with your application code or those live separately, the infrastructure should follow the same deployment model as your application code. Consolidating review and change management processes into Git as the source of truth and your approval mechanism is another way to help modernize and speed up your deployment cycles. Use opinionated tooling when possible. So this is where we have tools like the AWS Cloud Development Kit or the AWS CDK, the SAM CLI or the Copilot CLI that all have built-in good practices. This saves time and effort and allows teams to focus on their differentiators as a business and not the infrastructure. In the same vein, when choosing where to run your code, understand what comes with each choice and only manage the infrastructure if you absolutely need to. Now that we've briefly touched on modern architectures, embracing them, and some concepts around them, I want to talk about containers. So let's talk about containers and why they've become one of the de facto standards for folks building modern applications. Containers provide a standard way to package your application's code, configurations, and dependencies into a single object or artifact. This is providing a standard packaging model. This provides consistency across environments, including the age-old problem of, well, it works on my laptop, not sure why it doesn't work in production. Whether you deploy locally on your laptop or to production, the experience will remain similar with the exception of secrets and other environmental values, of course. And when I say environmental values, if you talk to a database, obviously you're not going to talk to a production database in development or from your laptop. Those are the type of values that change based on the environment and where you're running. Containers share an operating system installed on the server and run as resource-isolated processes, ensuring quick, reliable, and consistent deployments regardless of environment. As environments scale and microservices grow, container orchestration automates the operational aspect of running containers. Look at it as a way to connect the dots between your containers, ensuring that they're running at the desired state based on the desired state configuration that is defined. And it helps with monitoring, scaling, load balancing, amongst many other things. And oftentimes, when I speak of orchestrators, I relate it to an orchestra. You have a conductor that the conductor's job is to ensure everyone's on time, playing in key and playing as they are supposed to. That's what a container orchestrator does. Same thing. So now let's talk about running containers on AWS. There are options when running containers on AWS. And for me, it starts with AWS App Runner, which is a fully managed service that makes it easy for developers to quickly deploy containerized web applications and APIs at scale with no prior infrastructure experience required. The infrastructure is completely abstracted from the user as they simply provide their code or a Docker image, and App Runner will manage everything else. And when I say manage everything else, that means scaling, that means deployments, pipelines. It's all fully managed with AWS App Runner. But for customers that are looking for more control over how their containers run, there's Amazon ECS and Amazon EKS. Both orchestrators operate at large scale and support thousands of customers running millions of containers today. For the remainder of the presentation, however, we're going to focus on Amazon ECS, and we're going to walk through some strategies and best practices for running your containers on Amazon ECS. Let's start by talking about what Amazon ECS is. So Amazon ECS is a fully managed container orchestration service that helps you easily deploy, manage, and scale your containerized applications. It deeply integrates with the rest of the AWS platform to provide a secure and easy-to-use solution for running container workloads in the cloud or on your infrastructure with ECS Anywhere. In addition, there's no maintenance or versioning required on the ECS control plane. It's fully managed, and this simplifies the operational aspect of running a container orchestrator. So with that, let's talk about some strategies for running modern applications using Amazon ECS. And anytime I have a conversation with anyone, whether it's at a conference, on Twitter, wherever, it always starts with this. Think serverless first. Running containers on self-managed EC2 instances comes with its own challenges and costs. There's patching, there's scaling, and there's securing the access to the host itself. With AWS Fargate, customers don't have to worry about managing the underlying servers that their containers run on. This moves us up the stack. We're managing less, and we're focusing on the application and less on the underlying infrastructure. This is thinking serverless first. With Fargate, I don't have to worry about scaling the underlying EC2 hosts to meet the demand and scale of my containers. I focus on the scaling of my application, and that's it. And that's because with AWS Fargate, it's a one-to-one mapping of my task, my task is the definition of my container or containers, and that maps one task to one host. So it's always isolated to just your single task onto that single host in AWS Fargate. In addition, the security posture improves because we're eliminating a potential entry point by not having to manage the underlying host. Now, AWS Fargate is not the only way to run your containers on ECS. And It shouldn't be, because every use case is unique and different in its own way. So AWS offers a range of integrated compute options for where your containers can run. You can choose the right tool for the job and get the right blend of cost, performance, and features. So we talked about EC2 as a way to run your containers on ECS. And EC2 offers a wide choice of instance types based on processor, storage, networking, architecture, and more. This is ideal for customers who want to manage or need to manage or customize the underlying compute environment and host operating system. Then as we get to use cases where we, as the customer, needs to meet your customer at the edge, this is where we have AWS local zones, as well as AWS wavelength to run your containers closer to your customers. And lastly, there's the use case for running on-premise, which is where ECS Anywhere or AWS Outposts allow you to run your ECS tasks in your data center. Lastly, if you're going to use EC2, take advantage of capacity providers with cluster autoscaling. We'll talk about this again in a little bit, but this is a feature of ECS that will monitor your cluster based on resource utilization and reservation and automatically scale the EC2 infrastructure to launch new tasks when needed. This not only manages the scale out, but also the scale in. ECS is deeply integrated with the AWS ecosystem. Take advantage of the native integrations that are available to you. So this is just some of the services that ECS integrates with. I couldn't fit them all on this slide, so I just picked some high level to kind of show all the different levels of integration that are available. So let's talk about some of the areas where these integrations exist with a couple of examples. So the first one is storing your secrets and accessing your secrets. Secrets Manager and SSM Parameter Store, by defining a pointer in your task definition to a secret or a parameter name in SSM, you don't have to hard code secrets into your tasks or your code, in your task definitions or your code. With the proper permissions granted in the task execution role, ECS will grab the secrets or parameters and expose them as environment variables to your container at runtime. There's also AWS CloudWatch. Out of the box, ECS integrates with CloudWatch for logs and metrics. This saves you the time of having to roll out your own logging or metrics solution. Then there's the networking components, which is for example, AWS Elastic Load Balancing for automatic registration and deregistration of tasks, meaning when tasks come up, they automatically register to a load balancer. When they go away, they automatically deregister. There's AWS Cloud Map for service discovery, as well as AWS App Mesh when you're looking for a more advanced service mesh in your cluster. When it comes to managing state in your container, decouple the state from your container. And this means that you should be managing application state outside of the container because containers are ephemeral in nature. And when you need to manage state, it should live outside because containers will come and go. And as they should. The expectation is a container can fail at any time, and the scheduler's job is to replace that container seamlessly but without you as the operator having to worry about it. So if you need data from a shared file system, for example, integrate with Amazon EFS, which is another native integration example that you simply have a pointer in your task definition that points to a volume running a volume in EFS, and ECS will actually mount that to your container at runtime. Automation of deployments is key, and it's so critical. I can't harp on this enough. Automate your deployments with AWS developer tools or open source tools. ECS has integrations with native AWS services like I've talked about, but also has deep integrations with open source tooling like Jenkins, GitHub, GitLab, and so on. But we have an AWS native tool chain set and an open source tool chain that can work seamlessly with AWS container services. AWS provides services for modeling your application and its infrastructure. This is where we look at services like CloudFormation, the CDK, AWS Copilot, Docker Compose, etc. We also have services for source code and container artifact management like ECR and AWS Code Commit. But we integrate with AWS Code Pipeline integrates nicely with GitHub, for example, as an open source external alternative. And build-in integration tools like AWS Code Build, and then tools to help you deploy into production and then monitor those services post-deployment with AWS X-Ray, CloudWatch, Container Insights, and then AWS FireLens and the OTel collector, the Open Telemetry collector as well. But the key here is really to automate your infrastructures like you do your application deployments. And it's also a good practice if you're working in a microservices environment to couple those whenever you can. So I mentioned this earlier, but taking advantage of opinionated tooling with good practices built in will save you time and effort needed to build everything from the ground up. So, we look on the bottom of this slide, their infrastructure as code tools like AWS CloudFormation. There's also Terraform that can be used to define and build your environments. Now, these are powerful infrastructure as code tools, but require a deep understanding of the AWS environment you're building and deploying. Even if you have a deep understanding, the management and maintenance of these templates can become overwhelming. By leveraging tools like the AWS Copilot CLI or the AWS CDK, you can take advantage of the opinionated constructs and focus more on the application and what your application needs to be successful. The great thing about these tools is that when your use case grows outside of what the opinionated constructs provide, you can expand on them to define the additional resources that you need to make your environment work as expected. So, we always have to talk about security because, security is job zero and it should be top of mind. And by default, when you're operating in AWS, when you're operating in ECS, least privileged security is the model. And as the user of ECS, you should be following that model as well. So this means using IAM roles and attaching those policies and roles to the task via the task role to control what your containers can and can't access within AWS, within your AWS environment, and limit the access to only what is needed. By default, the task role doesn't have any permission to access AWS resources, so you should scope your permissions to be very specific to only what is needed and not everything out there. Use AWS VPC network mode when possible and control network access between resources using security groups. So this is a really powerful feature that comes with AWS VPC networking mode. And for Fargate, this is the only option available. But when you're operating on EC2, there are other networking options available like host, bridge, etc. But if you can, use AWS VPC networking mode. And when you're using EC2 in the data plane, disable access to the instance metadata service for your tasks running on the host. This will prevent the tasks from accessing or at least having the ability to access the IAM role attached to the EC2 instance. Then there's autoscaling. I will say, whenever possible, wherever possible, you should be thinking of how can you enable autoscaling? And it starts at the service level. Every service has its own requirements and its own bottlenecks. Through load testing and understanding your user patterns, you should have a good idea as to what the choke points of your application are and what metrics are needed to scale out and in. For example, if I have a container running and it's CPU intensive, I may want to use the CPU utilization metric as my scaling metric. But if I have a load balance service or a web service, maybe concurrency is my choke point. So if it's concurrent connections, I'm going to use that metric to scale my service out and back in. When using Fargate, as I mentioned earlier, one of the benefits is your focus is only on how your service scales. For ECS tasks running on EC2, the scaling dimensions do change a bit. When the service needs to scale, and there's not enough resources within the running pool of EC2 instances in the cluster, scaling has to take place at the cluster level in order for the services to scale out to meet their demand. If there's no resources available, your services obviously can't scale. So there are many approaches to this, and I just want to start with the less ideal approaches, which would be to have idle instances sitting around, which is basically you just have EC2 instances that are not being utilized, just waiting for the potential of the need to scale, or worse, paging someone in the middle of the night to launch more instances to support the load. Instead, use cluster autoscaling, which is a feature available within Amazon ECS. Cluster autoscaling factors in multiple dimensions in determining the resource reservation requirements for the cluster, and will automatically scale out the instances to support the desired tasks, as well as scale them in. So we talked about, a lot of the different operational models here and operating in ECS and best, good practices, but there's also cost efficiency. Now, if you're using EC2 in the data plane, as I touched on briefly in the previous slide, you want to keep an eye out for underutilized EC2 instances. A common pattern we see with customers is where EC2 instances are operating at 50% capacity, meaning they're running containers, but they're not being fully utilized. So you're paying for resources that you aren't even using. So look at using the bin pack strategy here when deploying to EC2. This will instruct the scheduler to pack containers onto EC2 instances to get the most out of your running hosts. And for non-production environments or workloads that are not sensitive to volatility, look at using spot instances. Customers can save up to 90% by using spot instances. And just a quick definition in short, if you're not familiar, spot instances are unused EC2 capacity that customers can use for a fraction of the cost of on-demand. But if you're using Fargate, there's also benefits here from a cost perspective. One, you don't have to worry or think about the EC2 utilization component. And two, Fargate also has an option to run on spot. And the Fargate spot model, customers can save up to 70%. The one thing to note with running and operating on spot is that when the demand is needed and AWS needs to reclaim those instances, they will reclaim the spot instances. They give you a 2-minute warning, and then essentially the tasks or instances are shut down and then they don't come back up until there's availability of spot again in that availability zone. So in addition to spot, Fargate and EC2 support Graviton 2. So Graviton 2 they're ARM processors that offer a performance improvement at a lesser cost. So it's highly recommended that you take advantage of Graviton 2 and ARM where you can. Lastly, take advantage of autoscaling. Scale in when traffic is low and scale out for the duration needed to support the demand. So I feel like, I've repeated that a few times, but the whole point is you really should be thinking about how can you use what you need when you need it, and then when you don't need it, get rid of it. So I want to wrap up with some other general best practices for running on Amazon ECS. And one of those starts with versioning of your container images with tags. So we always advise against using the latest tag for a couple of reasons. One, a common practice is to tag your images with the git SHA or maybe the semantic version that container is running on. And the reason here is if something goes wrong, you have a pointer to the code change, which shows exactly what was changed and all the changes that went in to that particular container image and to your application that's running on that in that image. So it gives you a quick troubleshooting point to find where the problem is and dig in. Also, when you use latest tag, it's very generic. So, you don't really know at what point in time you are with your code base. And also it makes deployments tricky as well. When it comes to logging, have your application log to standard out and standard error. Let the orchestrator handle the log routing. This is beneficial because it makes your container more portable, and the log routing can be changed at any time at the orchestrator level, and you as a developer writing applications don't have to worry about that. And lastly, use health checks. Whether you're running a load balance web service or a backend service, use health checks to help the orchestrator determine when a task is healthy and when it's not, so the orchestrator can shut those tasks down and replace them with healthy ones when the time comes. And one other thing to say about health checks that's really important. You don't want to health check the entire environment. The idea of a health check with microservices is you want to check the health of your application and your application only. That means if you rely on other external services, you should have a contract that defines what the uptime and availability is for those services, and you shouldn't have to health check those to determine the health of your application. That includes databases as well. So, because what happens is you could have a perfectly healthy application running in a container, and if one of the backend services you talk to is unhealthy, the orchestrator is going to be churning not only those backend tasks because they're unhealthy, but it's also going to churn yours. So this puts an unnecessary amount of load on the orchestrator and just causes a lot more problems when issues arise. Keep your container images lean. The smaller the container image, the faster the time to launch. In addition, this lessens the footprint when you're securing the image. So don't install a bunch of packages that you don't need in there. Only install what you need in the container image, and then ensure that you're cleaning up post-build. And there's ways to, there's good practices here, like using multi-stage builds, and clearing your package cache, etc. And then one other thing that I want to end on is safe and speedy deployments. So you have to understand each application is different, and how you deploy each application varies. So by default, the health checks that are the health check configuration out of the box is generally slower. And the reason for this is because we want to be safe. So the defaults are safe, and it's up to you to tweak them for performance. So that means for the load balancer, for example, working with elastic load balancing, the registration and deregistration delays. If you don't need 5 minutes for those to deregister a task, you can set that to as low as you need. And the same goes with Docker health checks. So you can configure your health checks based on what your application needs and how safe or how fast you want to go. And lastly, take advantage of circuit breakers. ECS has a functionality called circuit breakers for deployment specifically. And what they do is they will monitor the deployment. And if your deployment is failing, meaning your tasks come up and then they fail health checks, the circuit breaker will automatically roll back to the previous version if you enable that, or it will just fail the deployment. If you enable rollback, obviously this saves you the time from having to intervene. So that's it for this talk. I wanted to thank everybody for joining me today, and I want to guide you to some additional resources that are out there that can help you in your container journey, in your modernization journey. There's ECS Workshop, which has chapters on some more advanced concepts with deploying to ECS, as well as how to walk you through deploying a 3-tier microservices polyglot application to ECS. We also have a show as well as a YouTube channel called Containers from the Couch. And you can go to containersfromthecouch.com, subscribe to see all of our videos, as well as some of the new content that comes up every week or so. And lastly, a link to our best practices guide. And if you have any questions or you ever want to reach out to me, I'm available on Twitter. You can DM me, at me, as well as GitHub, where I may post some cool projects or some demos just to give you an idea how to do certain things within the platform. So I want to thank you again, and happy deploying.